Hello, let's continue our Sudoku adventure with Entropic Gravity by Crusader175. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these peach lines in the grid. These are entropic lines. So what you do is you take any group of 3 adjacent digits on the line. So this would be a group, this would be a group, this would be a group. So they do overlap each other, and that's on purpose. But any group of 3 lines is going to have one of each of a low digit, a medium digit, and a high digit. Low digits are 1, 2, medium digits are 3, 4, and high digits are 5, 6. So what that means is if I put, say, a 2 here, that's going to be a low digit. And so then for this group of 3, I would need a medium digit and a high digit. So maybe this is the high digit, maybe this is the 6, and maybe this is the medium digit. We can put a 3. And then now this group of 3 would also need it has a high and a medium already. It would need a low. And it just continues that way. Then this group of 3 would need all 3 as well. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Right, the first thing I'm going to do is I'm going to color all lows blue, all mediums purple, and all highs orange. That's just kind of the coloring I'm used to, and I've associated those with those groups. So the first thing I see, actually I see this a few times in this puzzle, but let's just start in the top left corner here. So there's already, this uses up all the box except a single blue. So that means there's only one blue on this line, and then there's 2 of each other color. Now, the thing that I know about entropic lines, and if you think about it, it's not too hard to prove. Let's just use alternate colors for this. Let's use red, yellow, and green. So what I know is that red, yellow, and green are one of each group. Excuse me. Red, yellow, and green are one of each group. We don't know which is which. One of them is low, one of them is medium, one's high. We don't know which is which. But what we do know is that they're all 3 groups are represented here because that's what the rules say has to happen. But what about these 3? We already have yellow and green. We can't put another yellow green, so we have to put a red. We have to have the other digit of the red group. And then here, these 3 already have a green and a red. We need a yellow. So entropic lines always end up going cyclical like this, where you have, in this case, red, yellow, green, then red, yellow. And then if we continued, we'd have a green. So it goes red, yellow, green, red, yellow, green, etc. Now, what do we notice about this? Well, we notice that the only cell that's part of a group that appears only once on the line, green, there's only one green cell on this line. That is going to be the blue, because the blue only has 1 cell on the line. The other 2 groups have 2 cells on the line. So this green is actually blue and it's a 2. The next thing I'm noticing is this red. There's 2 reds in this box and they share a column. And in this column, we already have a purple. So we already knew red wasn't blue, but now we know red can't be purple because we cannot put 3 purples in this column. Only 2 purple digits exist, the 3 and the 4. So these are not purple. These are orange, and they're from 5, 6. And then that out of process of elimination, that means these have to be purple. And this sees a 3. So that's 4 and that's 3. Nice. Okay. Now here we have something similar happening where we're going to cycle. So this is the odd one out that only has 1 in it. So this is the purple because we already have a purple in the box. That makes that 4. And then these 2 are going to be the same as well, just like these were. And it sees an orange. So these can't be purple, they can't be orange, so they must be blue. So this is 1 and 2, and then these are orange, 5, 6. Nice. Okay, now I guess we might as well think about this one here. So let's see. The odd one out is here, right? This is going to have to be purple because if you think, I can use my false coloring again. Red, yellow, green. Then we have to go back to red, and then we go to yellow, and then we go to green, and then we go to red. So in this box, the green is the one on this line that is going to match this 4 because you can't put another purple on here. So this is purple, and it's a 3. And these are every other, and they aren't purple. So we know that this includes a blue, and it includes a orange, a blue and an orange, one each. Now this green here actually matches this one. So actually we know this one's purple and it's a 4. Okay, so this red here sees 2 oranges and 2 purples. So actually we need 2 blues down here. So the red ended up blue and then the yellow ended up orange. So that's a 5, 6 pair. And actually this 5 tells us the order, 6 and 5. This is a 1, 2 pair. This 2 says that's 1 and 2. And then this is a 1, 2 pair and we can't resolve it yet. But here we need an orange 5. And then over here, we do need a 3-6 pair, but we don't know which is which, and we can't color them yet. Okay, now we'll do the same thing here. I will false color again. So red, yellow, green, red, yellow, green, red. The odd one out is this green. That means green is orange. You get the drill by now. So we get our 6 and our 5 here. That gives us 6 and 5 and 6 and 5. And then here we have 2 blues and 2 oranges. So this is very symmetric. We get 2 purples here. And so that was red. So red is purple. And then yellow is blue. So that's a 1 and a 2. This is a 4 and a 3. This is a 3 and a 4. That gives us 6 and 3. 6 is orange and 3 is purple. Okay. This has to be a blue 1. That's a 2 and a 1. And then over here, so this row is going to need a blue. This row is going to need an orange. And then we know that's the 2 and that's the 6. And we're done. Very nice. Very symmetric and repetitive use of the same concept, but it really drilled it in. So a nice introduction to entropic lines and how to think about them. And coloring definitely helps. So if you have the coloring idea in your toolbox, it really, really helps with entropic lines and understanding the concept of how the overlapping forces that cyclical nature of them. So cool. I enjoyed that puzzle. Thanks, Crusader. Hope you enjoyed it as well. If you did, then why don't leave a like, subscribe, and a kind comment below.